Welcome back to another metrology and measurement session. So today we are going to discuss about the fourth unit in the metrology and measurements, ME3592, and the topic of the fourth unit is metrology of surfaces. My name is P.NAVIN, JASS, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. The fourth unit is metrology of surfaces. So this is the syllabus we are going to discuss in this unit. Fundamentals of geometrical dimension and T-conventional, fundamentals of geometric dimension and tolerances, then conventional tolerance and geometrical tolerance and datums, and inspection of geometric like deviations in straightness, flatness, roundness, deviations, and some simple problems are also in this unit. And the main thing in this unit is measurement of surface finish, functionality of surfaces, then parameters, and the main important topic we are going to discuss in this unit is stylus based and optical measurement techniques, then filters and introduction to three-dimensional surface metrology. And this is the course outcomes. After the completion of this unit, after the discussion of this unit, students can able to select the principles and methods of the form and surface metrology. So students can able to select the principles and methods means so they can able to find out the best option to measure the surface of the materials and flatness of the materials and dimension of the materials and tolerance of the materials. So first we are going to discuss about the straightness measurement. So here the straightness is nothing but is a geometrical shape. So this straightness is a type of geometrical shape. So here the geometrical tolerance for straightness will be specified if straightness is to be attained while manufacturing. So the straightness is nothing but it is a line to be a straight over for the given length. This line is contained between two imaginary lines that are placed equal distance of the surface, and this line being tested for straightness. The entire surface and the line on the entire surface is being tested to find out the straightness measurement. So the two distances between the imaginary lines is to be equal to the specified of the straightness tolerance. So the straightness is a condition where an element of a surface or an edge is in a straight line. The tolerance on the straightness of a line is defined as the maximum deviation in relation to reference straight line joining two extremities of the line to be checked. So this is in the figure we can able to see the geometrically ideal line. So this ideal lines, this geometrical ideal line is the center for the imaginary lines. So at the edge of the imaginary lines, geometric tolerance for straightness is to be checked, and the line straightness is to be tested. The lowest point on the actual line is to be found out, and the peak line is also found out with the help of geometrical ideal line. So we can able to find out the straightness of the percentage of straightness of the particular element. So here we are using some measuring instruments for find out the straightness measurement. Some of the measuring instruments are straight edge, spirit level, and autocollimator. So straight edge is the normal measuring instrument, and spirit level is also a normal measuring instrument. So these two already we studied in the second unit. So I'm going to tell simple details about these two, straight edge and spirit level. So first, straight edge. This straight edge is the flat length of a tool steel. It looks like a stainless steel that is ground to extremely fine the tolerance along its edges. These straight edges are available in the market from 30 centimeter to 360 centimeter length. It is used to check the surface for straightness, and it is used to scribe accurate straight lines. And the second one is spirit level. The spirit level is normally used in the building work areas. When we place the spirit level on the surface of the material, at any length of the surface of the material, the center of the spirit level, there's a bubble which will be constantly placed at the center of the tube. So we can able to find out it will be a straightness on the surface. If this bubble is varying right side or left side, there is no straightness is available on the surface. So this spirit level is used for that purpose. This spirit level can measure angular displacements related to horizontal datum and the level of liquid at rest. Then the third one is autocollimator. This autocollimator is used for find out the straightness of the surface. The straightness of a surface of any length can be tested using this autocollimator. This autocollimator which have its higher degree of accuracy, so we can able to collect the perfect output from this autocollimator. It is used on vertical side of horizontal slideways, and it has a converging lens with a point source of light its principal focus. So this autocollimator is also already we studied in the second unit. So in this there's a principle of the autocollimator is present. When a parallel beam is projected on this point, and if a plane reflector is kept 90 degree to the beam of light, the light will be reflected back its own path, and it will be brought to focus at the same time as that of the light force. This light is reflected by an angle theta. The parallel beam light will be deflected by twice the angle will be brought to the focus in the same line as the light source, but to one side of it. The image and object will not coincide, but will be placed at a distance of 2 theta f. When we see this, there are 2 points are there. So the initial point is started at this point, and it will be reflected, and the end point will be found out on this area. So there is a distance between the initial point and the end point. So this point is called as 2 theta f. So by this principle, we can able to find out the deviation of the flat surface. And the next one is flatness measurement. So by this method we can able to find out the flatness of the surface. The simplest form of flatness testing is possible by comparing the surface with an accurate surface. So this flatness testing is also similar to the straightness testing. This method is suitable for small plates, but it will not be suitable for large surfaces. The flatness error of a surface states the departure from flatness. It is the minimum separation of a pair of parallel planes which will contain all points on the surface. So there are some procedure to find out the flatness of the surface. So here I'm going to tell the procedure to find out the flatness of the surface. So this is the flatness testing procedure diagram. By this method we can able to find out the flatness of the surface. A surface can be considered to be a collection of large number of lines. If all these lines are straight and lie on the same plane, the surface is said to be flat. So we are going to consider a rectangular shape table. All the generator lines are straight and parallel to the sides of the rectangle in both the perpendicular directions. For a surface to be truly flat, the diagonal lines should also have straightness. So here all the lines are having straightness. So here the end lines of AB, AD and BD are corrected to 0. Which are the lines are there? Here AB, AD and BD are corrected to 0. That's so the height of this end of lines AB, AD and BD are corrected to 0. Here the lines AB, AD and BD are corrected to 0. So that's the height of the points AB, D are 0. So these points A, B, D are 0. The height of point I is relatively determined to the arbitrary plane ABD 0, 0, 0. So these ABD points, ABD lines are relatively determined to the point I is equal to 0. Point C is fixed relative to the arbitrary plane and points B and D are set at 0. All the intermediate points of BC and BD can be corrected accordingly. So relative to the point C, these points are corrected accordingly to the value of 0. The positions H and G, E and F are the known positions of the value. So it is now possible to fit in lines HG and EF. It also provides a check on previous evaluations, since the midpoint of these lines should coincide with the known position of midpoint I. In this way, the height of all points on the surface to the arbitrary plane ABD is known. So with the help of this method, we are going to find out the flatness, and also we can able to test the flatness with the help of the interferometry. This interferometry is a monochromatic light source, and set of optical flats are used in this interferometry. And when an optical flat is placed on another reflecting surface whose flatness is to be determined, the optical flat will not inform an intimate contact, but will lie at some angle theta, making an inclined plane. So the optical flat is illuminated by monochromatic source of light. If the eye is placed in the proper position, it will observe a number of bands. These bands are produced by the interference of light rays reflected from the bottom surface of the optical flat and the top surface of the test surface through thin layer of air between surfaces. At a point A, the wave of incident beam from S is partially reflected along AB and is partially transmitted across air gap AC. At point C, the ray is reflected again along CD and extends along point E. Thus, the two reflected components have a traveled path whose lengths differ by an amount ACD. If the path lengths of the two components differ by an odd number of half wavelengths, complete interference is achieved and a straight dark line will be seen passing through the point C. So, there's a path difference of odd number of half wavelengths, interference will occur and a similar dark fringe will occur. At intermediate points between point C and H, the path difference is an even number of half wavelength. As the components are in phase, a light band is produced. So the light and dark light straight line bands are produced. A deviation is from this pattern becomes a measure of error in flatness of the test surface. So by this topic we are going to conclude this session. The next session we are going to continue this unit for the better to gain the knowledge and to find out the principles of which we are going to use to measure the surfaces on this unit. Thank you.